Hi everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. In the previous video, we derived the IV estimator as beta IV equals to covariance of z over covariance zx. Along the way, we mentioned several names like indirect least squares, reduced form, intent to treat. This short video clarifies what each term means and how they relate to each other. You have to remember, in any IV strategy, usually there are always three regressions that are always checked. Whether you show them in your dissertation or not, you still do that little background check. And those are the first stage regression. The first stage regression, it's something that you will always show anyways because that's your relevance condition. But basically, you're running a regression of X on z plus an error term. Then the next one is the reduced form, where you're running a regression of y directly on z. And then ultimately is the structural equation, which is what you need. The structural equation is simply y equal to beta 0 plus beta 1x plus u. Keep in mind, x is our endogenous variable. Now, the first stage and the reduced stage, you can estimate through OLS. The structural equation is what you cannot estimate through OLS because you're going to have biased and inconsistent estimators. However, IV recovers those true effects, okay? So it's a good strategy, it's a good habit to have to always run and report all three. The first stage showing the relevance, the reduced form is showing you the total effect of the instrument on the outcome. And together they tell the complete IV story, and basically the structural equation is where they are combined. The reduced form is regressing directly the Z on the Y. Now, we know that we are always talking about how Z affects X and then affects Y through X as a channel. In the auxiliary regression of the reduced form, we've got this gamma 1 hat that is measuring the total effect of the instrument on the outcome. And it's doing a lot more than that. It's actually combining two things. It's combining the effect of Z on X, okay? So this combines two things. The effect of Z on X, which is like the first stage, and also the effect of X on Y, okay, which is beta 1 hat. So in fact, try to think of this gamma 1 hat. If you had to rearrange the beta IV formula, it's simply as pi 1 hat times beta 1. Okay, so this relationship is quite important because it means the reduced form is not independent of the other two regressions. It is the product of them. And this has subtle but important implications because an insignificant reduced form could mean two very different things, okay? It could mean that the instrument is weak. So if pi 1 hat is approximately 0, that means you have a weak instrument, which means you have a relevance problem, okay? And the second thing that it could mean is that the true causal effect is 0, which means your beta 1 hat, the OLS one, is 0. So the second one is not a problem with the IV, but it means it's just a null result. There's no point in you actually studying these things. So if the first stage is actually strong, but the reduced one is insignificant, that in itself is actually informative because it suggests that the true causal effect is close to 0. But if both are significant, then the instrument is likely weak and the IV has little to work with, okay? So the reduced form is, in a sense, the most assumption-free result, because the reduced is, it's basically telling you that it requires no assumptions about the exclusion restriction. It simply asks, does the instrument predict the outcome? Okay, and it's a pure OLS regression, no IV assumptions, exogeneity, endogeneity required. So this is why most of the times good IV papers that are published, they always report the reduced form alongside the IV estimate. And readers that way can see the role relationship between Z and Y before any structural interpretations are imposed. Some journals and referees specifically actually ask for the reduced form to be reported. So if your reduced form is weak or fragile, that raises questions about the entire IV strategy. So regardless of whether the IV estimate looks significant or not. Moving on to the intent to treat. In program evaluation, and especially medical research, the reduced form coefficient is called the ITT, or intent to treat effect. Imagine a job training program, okay? Where let's say Z is equal to 1 if you're offered the program, okay? X1 is whether you attend it. Okay, so Z1, it's offered. X1 is attended. And you've got Y, that is earnings. Okay? The ITT is asking, what is the effect of being offered the program on earnings? So not everyone actually who has been offered is going to take up on that offer. So the ITT in here is going to capture the average effect across everyone who was actually offered that, including those who didn't take up the offer. The ITT is often the most policy relevant quantity. In a sense, a government offering a program cares about the effect on everyone if it offers it, not just those who attend. So the ITT answers that question directly without requiring any IV assumptions beyond the first stage. And ultimately, the last element that we need to quickly recover is the ILS, indirect least squares. Keep in mind, this is the procedure recovering beta 1 hat from OLS regressions, okay? As you remember, the beta IV is gamma 1 over theta 1. The beta ILS is also gamma 1 hat over pi 1 hat. But instead of running 2SLS directly, you run 2 OLS regressions. So you run the first stage plus the reduced form, okay? And divide one coefficient by the other. So this indirectly recovers the structural coefficient, and hence the name indirect least squares. So basically with the indirect least squares, what you're actually doing is rearranging this equation and getting the what we mentioned in here, this gamma 1 being the theta 1 times beta 1, or the opposite, okay? The word indirect in here reflects the fact that we never directly regress the Y on X, okay? So never Y on X, because that would be useless when X is endogenous, but we go via Z indirectly, okay? To recover the causal effect. And because gamma 1 hat is actually pi 1 hat times beta 1 hat, dividing through by exactly pi 1 gives back the beta 1 exactly. Now, when do 2 SLS and ILS agree? In the just identified case, where you have one instrument and one endogenous variable, the ILS and the 2 SLS are going to give you exactly the same answer, okay? They are mathematically identical in this case, and ILS is simply a more transparent way of presenting 2 SLS, showing the two building blocks explicitly. This is why presenting sometimes gamma 1 hat and theta 1 hat alongside your IV estimate is considered good practice. So it shows exactly where the estimates come from and makes the IV logic completely visible. But they also disagree or differ in the over-identified case, meaning you have more instruments than endogenous variables, because in this case, the ILS actually becomes ambiguous. With two instruments, Z1 and Z2, you have multiple reduced forms, okay? Because you would have gamma 1 from Z1, and then you'd have gamma 1 hat also from Z2, and what if the two of them differ, right? Which ratio should you be using? So ILS doesn't have a clean answer in the over-identified case, while 2SLS does because it optimally combines all the instruments to produce a single efficient estimate. This is why 2SLS is the standard method, while ILS is useful for intuition, transparency in just identified cases. But again, 2SLS, very powerful and generalizes correctly to over-identification, while ILS does not, okay? The relationship that connects all of these three concepts all over again is simply gamma 1 being equal to pi 1 hat times beta 1 hat, okay? So the reduced form is the product of the first stage and structural effect. IV recovers structural effect by dividing one by the other. The reduced form, intent to treat, and indirectly square are all versions of this formula. And again, this will equal 2SLS in the just identified case, but 2SLS is preferred in the over-identified case where ILS becomes ambiguous. In the next video, we'll work through a complete numerical example, computing the first stage reduced form and IV to estimate step-by-step and verifying basically ILS and 2SLS give the same answer. So stay tuned and I'll see you in the next video.